Welcome to this video where we are looking at ratio strength, another way of expressing concentration in pharmacy practice and is applicable to semi-solid calculation. Remember now that ratio strength and percentage are interrelated, and so you can't really talk about one without talking about the other. Ratio strength is really created to eliminate percentage expression filled with zeros and decimal. In my layman term, that's what I understand from it. Ratio strength is almost always used to describe the active ingredient in relation to one part compared to the dilution. So for example, 1 gram of the drug in 2,500 milliliters of a liquid. 1 gram of the drug in relation to 2,500 grams of the preparation or the stock that is being used. So let's recall, if you're dealing with a weight in weight semi-solid, it's percentage weight in weight. So it's 1 gram in, say, 500 grams. If you're dealing with a weighted drug in a liquid system, then you're dealing with 1 gram in, say, 1,500 milliliters. Okay, and remember percentage, we talk about milliliters. And so if it's volume in volume, you're talking about 1 mil in, say, 5,000 milliliters. And so because these are very diluted systems, the concentration expressed as percentage would almost be like 0.0125%, 0.0025%, 0.0089%. And so to eliminate percentage expression that involves zeros and decimal, ratio strength is so beautiful for that. And so let's look at it. 1 in 250 for a liquid means 1 mil in 250 milliliters of that product or that stock. And so when we're talking about semi-solid calculation, please make the distinction between the product as opposed to the stock material being used to make the product. If you're seeing 1 in 250 for a semi-solid, then that means 1 gram in 250 gram, as I've expressed before. Now let's look at this question. A stock ointment is available as a concentration of 1 in 400. Express this as percentage. Really simple. So I'm going to show you 3 ways you could have document and solve the question. 1 to 400 using dimensional analysis is 1 over 400 times 100%, which is 0.25%. Real simple, right? Now let's look at it. 2 other ways you could have documented, as I showed you in the previous video, using cross multiplication and fraction format. And the third method is using means and extreme, which always ends up giving you the same. Look at it. A times D. Look at it. A times D. B times C. B times C, of which one of this will be unknown. But let's see how we actually use it. For cross multiplication, 1 to 400, we already know. Percentage is 100, so we already know that too. And so the unknown is what is the decimal form of the concentration in 100 mil. And so here 1 over 400 times x over 100, because percentage is out of 100, we're trying to solve what is the concentration out of 100. You set up your 1 times, cross multiply, make x the subject, and so you have 100 over 400, which is 0.25%. That's the cross multiplication using fraction layout. Now let's look at means and extreme. It's another way of documenting ratio and proportion. It's in your PharmCal textbook. It's also in many other pharmacy calculation books out there. So the extremes would be, let's show you how I wrote the extremes. 1 is to 400 as x is to 100. And so here, 1 is A, 400 is B, C is the unknown, and D is the dilution, and the D here. So once you made the unknown the subject of the calculation, you get the same thing that we did using the fraction cross multiplication template. And so your answer is 0.25%. And that is really it. Can you imagine? 3 ways to solve ratio and proportion. Explore the topic and see which one you are most comfortable with. Don't forget to like this video and subscribe to the channel if it has been beneficial while I develop more content like this for you. Thank you.